Hey everyone, this is the first part of the demonstration of my thesis project. Here we have on the left side we have we have a set of code under IoT, and there is this deployment file that explains step by step what are the things being run on the laptop, which is acting as the blockchain server, and what is running on the Raspberry Pi, and how we're making sure that the Raspberry Pis, which are the primary group heads for our blockchain project, interacting with the actual blockchain server. The first part here that I would like to explain is that this set of code is actually deployed on each Raspberry Pi, and they are using this set of code to interact with the blockchain access control, which is which is the main repository here. We had a local deployment first to check if everything was in place and working before we moved the code to the Raspberry Pi to make sure that the actual setup is working as intended. I will take you through the primary head.js. This is a JavaScript service that implements a full primary group head backend for the Raspberry Pi. It primarily acts as a blockchain access backed access control gateway that will expose the REST APIs to be able to not only register devices but also deploy access control contracts. So basically, the contracts are here within the blockchain side. So this laptop here will have all the contracts that we need in order for the primary group head to interact with itself and with other primary group heads, and also with its regular members. That's the ESP32 devices that we have connected with each Raspberry Pi. So I'm going to take you through the steps needed to run this. I'm going to first close the existing blockchain wallet that's running. We're using Ganache, and as you can see here in the code, command, that we are first killing the previous Ganache service, basically to make sure that it doesn't overlap. And then after that, we are also temporarily removing the keys that are being stored here. So whatever Ganache is generating, the 25 test addresses with its private keys will be stored in this JSON file, which will be used by both primary group heads in order to interact with the blockchain service. And after that, we are just spinning up the wallet. I'm just going to press enter here. Yes. This, we need to make sure that no existing service is running. So I'm just going to kill. Well, it should be killing off the service by itself, but even nonetheless, we're just going to run this again. And now it's running, and this is the first part. The second part is the bootstrap, where we have a script prepared which automates everything that we need to do. It's sync to pi.sh, and essentially what it does is that it fetches all the relevant information to replicate all the addresses and the required ABI files into the actual Raspberry Pi by performing an SSH, and dump all the important information, relevant information that is needed for the Raspberry Pi to act as a primary group head. So for that, what we're doing here is we're specifying the server's IP address, which is this laptop right now, and then we're also specifying the IP address of the Raspberry Pi and the username, and then we're just running this script that performs everything that is needed for the Raspberry Pi to act as a primary group head. I'm just going to press enter here. It asks for the target PGH. We have 2 in this case, so we're going to go with A here. And after that, it migrates all the addresses into the files here, so you can see. Wait. So there is a temp folder. Okay, here it is. So this is where all the addresses are stored. Essentially, these are the same set of addresses that are here. It just moves to this, and also the .env file that is required in order for well, the primary group has to interact. So when we generate this file, automatically generates, and we're going to, I mean, basically the script is going to use that set of files and send it across the Raspberry Pi. And yes, so with this, I can check my Raspberry Pi and see that the addresses have been updated. Not just that, it also sends the updated key files and the env file and the APIs. Everything is mentioned here in the deployment documentation, where we have this set of addresses that needs to be updated, and once that is done, the Raspberry Pis can now act as the primary group head and interact with the blockchain access control.